Aluminum is a very reactive metal lying between magnesium and carbon in the reactivity series. Because it's more reactive than carbon, it cannot be extracted through the more common way of metal extraction, using a blast furnace. Due to its higher reactivity, it forms more stable compounds in its ores, and carbon monoxide is too weak of a reducing agent to reduce the aluminum oxide, which is its chemical form found in its most common ore, bauxite. Instead of using a blast furnace to extract aluminum and other reactive metals, we have to use electrolysis to separate the metal from its compounds. Electrolysis is the process of utilizing electricity to initiate redox reactions to decompose an electrolyte. In the case of aluminum, we have the following setup. Here. This is a diagram of an aluminum oxide electrolysis tank. In the tank, we have aluminum ore, Al2O3, dissolved in molten cryolite, which is here. Because aluminum oxide has a high melting point of 2045 degrees Celsius, we dissolve it in molten cryolite, or sodium aluminum fluoride, which has a much lower melting point of 1012 degrees Celsius. It will be very expensive to maintain a temperature of over 2000 degrees Celsius, so dissolving the aluminum oxide in molten cryolite helps reduce the energy costs of electrolyzing it. However, maintaining these high temperatures increases the cost of electrolyzing aluminum as a whole, and although it is the most abundant metal on Earth, it is somewhat expensive due to the cost of extracting it from its ores. This tank is set up with graphite cathodes here and here, and coke anodes there, there, and there. We use carbon electrodes because they are inert, but we use coke as opposed to graphite as the anodes, as they are used up during the process, and coke is less expensive as a form of carbon than graphite to continue to use up in this electrolysis tank. This helps to further reduce the costs of extracting aluminum. Now for the actual chemistry, at the cathode, here and here, aluminum ions are reduced to form molten aluminum. This is the equation. 4Al3+, as in the liquid state, gains 12 electrons to form 4Al, also in a liquid state. The molten aluminum then formed is denser than the dissolved aluminum and then sinks to the bottom of the cell, here, where it is tapped off at intervals. At the anode, at the anodes here, here, and here, the molten aluminum the oxygen ions from the aluminum oxide is oxidized to form oxygen gas. The equation is here. 6O2- in a liquid state goes to give 3 oxygen molecules in a gaseous state, and it loses 12 electrons. Because these anodes here, here, and here are made of carbon, the carbon reacts with the oxygen formed during the electrolysis process. This is this equation. Solid carbon reacts with gaseous oxygen to form carbon dioxide, which is a gas. This oxidation of carbon causes the carbon anodes to be reacted away and require replacement, hence the usage of coke over graphite. The overall reaction equation for the breakdown of aluminum oxide into aluminum and oxygen is this. 2Al2O3 in a liquid state, which is aluminum oxide, goes to give 4Al in a liquid state plus 3 oxygen molecules in a gaseous state. Due to the large cost of maintaining a strong current throughout the process, aluminum is a very expensive metal. However, its usage in our everyday lives is important. Because of its low density and strength as an alloy, it is used in aircrafts such as the wings and planes, here. In addition, due to its electrical conductivity and low density, it is used in overhead wires in preference to copper because copper is denser, though it may be a better conductor of electricity, here. It is also ductile, allowing it to be drawn into these long wires, which you see in the picture. Because it forms an oxide layer that acts as a barrier, aluminum is resistant to corrosion. This allows it to be used in food containers, here. Also, and lastly, because it is lustrous, it is used to coat CDs and DVDs, as the shiny surface of CDs and DVDs must be used to reflect the laser beam that reads the disc. The sources I've used to create this project are these. BBC Bite Size, which is my main source, our chemistry textbook, And for quick information, I use Wikipedia and uses of .net. Thank you.